Okay, so let's start going through this quiz. This quiz will be the first part of your Test 2 review packet, right? Test 2 should be in a couple weeks. We'll probably have 2 more weekly quizzes and then our next test. So number 1, x minus 4 over 2x plus 5x minus 3. One of the first things I usually do is I factor this thing out. This is x minus 4 over 2x minus 1, x plus 3. So clearly, if you factored wrong, you're going to miss the vertical asymptote points, but you still could have gotten your limit points. I hopefully slowed down and graded that closely. If you think I messed up, show it to me, I'll give you the point back. So for y-intercept, we clearly have a y-intercept at 0, 4/3. There's still a lot of, well, a lot is a relative word. More than I should be seeing in honors pre-calc, people writing the coordinates backwards, 4/3, 0. That is not a y-intercept. It happens a lot. Secondly is the x-intercepts. You have one at 1/2. Nope. You have one at 4. Set the top equal to 0 and solve. Okay, so that's 4 is 0. So there's 2 points. There are 2 vertical asymptotes, one at -3. So let's write the limit as x approaches -3 from the left of our function. A lot of people really messed up the limit notation. Now, it was not the only notation I would have accepted, but a lot of times I think people attempted the limit notation and really wrote it incorrectly. Try and learn the right way to write these things. It's LIM, and underneath it is your input variable, which in this case is s, the arrow, and then the number that it is approaching. And if it's a one-sided limit, there's a direction symbol above the 3, not above the x. Then there's the actual function you're going to be using to generate the output. So you have the limit of f of x, and then an equal sign. And so I believe in this case it was going down the left side of that vertical asymptote. As you approach -3 from the right, I think it goes up. Then we had another vertical asymptote at x equals 1/2. So the limit as x approaches 1/2 from the left of our function f of x is positive infinity. The limit as x approaches 1/2 from the right is negative infinity. Agreed? So far, 1 point for that's 1, 2, 3, 4, 5. There's 6 of the 8 points right there. The only thing left is to analyze the end behavior, and for this particular graph, that is a horizontal asymptote with the equation y equals 0. And so then the only thing left is to draw this. So horizontal asymptote right along the x-axis. Y-intercept at 4/3, x-intercept at 4, vertical asymptote at 1/2, vertical asymptote at -3. Is that it? And then as I approach the left side, I'm going down to negative infinity. The right side is up. What's the left side of the other vertical asymptote? Also up. A lot of people drew this U in such a way that it was crossing through the x-axis. So therefore you were showing me 2 extra x-intercepts that you did not list over here, so that missed you a point. And then, this is the weird one. It has to go down the right side of this vertical asymptote. It can't touch this and bounce away, so it has to cross through, but because that horizontal asymptote is 0, it must come back down. And the reality is, if you actually start plugging numbers into this function, the height of this hill right here is really, really small. Okay, so mine is extremely exaggerated. It really only goes up to like 0.02, actually. But then it comes back down and approaches the horizontal asymptote 0. Okay, any questions about number 1?
There's a horizontal asymptote, that means it's not a slant asymptote?
Yes. Right. Did you draw a slant asymptote?
No, I just wrote slant asymptote, that's why.
And I took a point off?
Yeah.
I may not have done that later on. I might give you a point back. I may have changed my mind. on like problem 2. A lot of people were doing that. I thought I only took a point off if you drew it in there.
I didn't.
Okay. I'll have to look. Did you state the horizontal asymptote also?
Yeah, I put y to 0.
And the slant asymptote?
Yeah. Well,
Okay.
I'll
Yeah, I'll look at it again. Okay. Number 2. Number 2 I thought was maybe the easiest problem on the quiz. Maybe. Or what was this? When I print this thing to OneNote, it doesn't. So it's 3x squared minus 3x minus 6. Is that correct? If you were to factor this out completely, that is 3x plus 1, x minus 2. The denominator is a negative x plus 3, x minus 1. Pretty easy to factor. In the numerator, factor a 3 out. Then it's really easy factoring. In the denominator, factor out a negative, and then it's really easy to factor. So as we start going through this, the y-intercept, negative 6 divided by 3, so that is 0 comma negative 2. X-intercepts, we have one at negative 1, 0, and we have one at 2, 0. And there are 2 vertical asymptotes. One has the equation x equals negative 3, so let's look at those limits. The limit as x approaches negative 3 from the left of this function. That is what? Negative infinity. And then the limit as x approaches negative 3 from the right of this function is positive infinity. We also have a vertical asymptote at x equals 1. So the limit as x approaches 1 from the left, that was also negative infinity. The limit as x approaches 1 from the right was positive infinity. Okay, any questions on these limits? Do you want me to go slower through it? Which one?
The limits of 1. Like approaching 1 from the left and the right.
From the left and the right. So as we approach 1 from the left, so we're thinking a number like 0.9.
Yeah.
Well, 3 is always positive. 0.9 plus 1 will be positive. 0.9 minus 2 will be negative. So positive times a negative, the numerator will be negative, yes.
So we do involve 3.
Absolutely.
Okay.
Now, the thing is, it's positive, so it won't matter. It won't change anything.
Okay.
But the negative sign here, that is important. So you're going to have a negative times a positive times a negative. So the top was negative, the bottom is positive. Negative divided by positive is negative, so it's negative infinity. Because of that negative sign. Absolutely. If you factor that negative out and it went away, that's a totally different function. Right? That's like me saying, hey, 6 is 2 times 3. I'm going to factor 2 out, and I'm going to call that number 3 from now on. Is 6 the same thing as the number 3? No.
Like what I did is I had that same numerator,
Mm-hmm.
and in the denominator I did 1 minus x times x.
That would work.
But then you don't have 3 signs on the bottom.
It doesn't matter. Because what if we did 1 minus x? When I plug in the number to the left of 1, like 0.9, 1 minus 0.9 is positive now. So you end up with a negative on top, a positive times a positive on the bottom. It's still a negative divided by positive, which is negative infinity. I think maybe you were still treating it like x minus 1.
I think I just messed up.
Yeah, probably. But no, you can totally write it as 1 minus x. And it's guaranteed you're going to get the same behavior. Absolutely. Okay? And then finally is the end behavior. So there's a horizontal asymptote with the equation y equals negative 3. You can get that just by dividing the leading coefficients because this is a balanced rational function. So if you were grading this, that is 1, 2, 3, 4, 5, 6, 7, 8, and then 1 point for the graph. So this is a 9-point problem. Okay.
Will it ever be the same, like, will it ever be like positive infinity, left and right?
Could be. Yep. We have not seen one, but it could happen. In fact, if you were to graph 1 over x squared, that's a graph that looks like this. It goes up on both sides of the y-axis. Okay, so let's graph everything we found here. Horizontal asymptote y equals -3, vertical asymptote x equals -3, vertical asymptote x equals 1. -2 is a y-intercept, -1 is an x-intercept, and +2 is an x-intercept. As I approach -3, I should go down to -infinity, so there's a branch. Positive infinity on the right side is asymptote. You cross through those intercepts, and then down the left side of that asymptote at 1. Then I believe it's positive infinity on this side. Cross through the x-axis, and then approach your horizontal asymptote. Okay, yes?
Why is crossing the horizontal asymptote okay? Crossing through and just not coming back to it.
It does come back to it. It crosses through it, and then over here it comes back to it. This is all one graph. But yeah, it crosses through it around the origin, around 0, but it eventually comes back to it as x gets bigger. A horizontal asymptote is called end behavior. It only tells you what the graph looks like when the inputs get extreme. When the inputs aren't extreme, it doesn't tell you anything. So that in reality, I maybe shouldn't even draw it in the middle. Just draw it from here over here.
Okay, on future graphs, do you want us to just graph what we find? Because on this one, I spent probably 5 minutes trying to find a couple other points because I didn't know how exactly we wanted it. But
right.
As long as we have.
As long as you
okay.
you have enough information to draw this.
Okay.
Absolutely. Now, in reality, maybe this branch here is actually going through this point. I don't
okay.
care. I'm not going to be picky about that. In fact, I think some people did that, and it looked like they plotted some points. I think it was problem 1. It looked like they were plotting some points to where it didn't look like it was going to approach the horizontal asymptote, or they were plotting points that I knew were way too high. So sometimes when I see points, if they're not perfectly correct, it's going to be more likely to take a point off if they were not right. If they're right, clearly it's fine. So any questions on number 2?
It's kind of off topic. Can we expect no use of graphing calculators for the actual temperature test?
I would, right now my thinking is, it all depends on how I feel after finishing grading these quizzes. Here's the only class I have completely graded. I have problems 1 through 2 graded for everybody. So I have to grade problem 3 for everybody else. If after grading them, I decide that in general, at a high percentage, and right now 75% to me is high enough, that you've shown mastery of it, then I don't need you to do that again. Does that make sense? You've shown me that, yeah, you can do this pretty well without a graphing calculator. So on the test, I'd probably allow it. Okay? But then I would expect everybody to master those at 100%. 1, given this quiz to look over and get better. 2, a graphing calculator should be even higher than 75% then. All right, finally, number 3, my favorite. Okay, so if we were to write this in factored form, that is x. You can factor an x out. Then you have a simple quadratic, x plus 3x minus 2. How nice was I? You didn't have to use any guess and check. X minus 2, x plus 1. First thing I noticed is that common factor in the top and the bottom, x minus 2. And the thing is, that factor is only a factor of the top and the bottom once each. So I actually know for sure that's going to be a whole, but I'm still going to do the limit to prove it. So we start going through this. What's the y-intercept? 0 divided by -2 is 0. Okay, log.
And if you said that it would be x minus 2, 1 on top, 1 on bottom, you know for sure that's okay.
Right. The only way this could actually still be a vertical asymptote is if x minus 2 shows up in the bottom more than it shows up in the top. If that factor shows up more in the bottom than the top, that will actually be a vertical asymptote. If it shows up equal or more in the top than the bottom, it's a whole. That's actually how that works. Because when I cancel them away, when I cancel this common factor, will there still be an x minus 2 in the bottom, making the bottom 0? That's what's guaranteed to be a whole. Okay? So, y-intercept at 0, x-intercept And just to let you know, I'm grading your work mostly. If I didn't see y-intercept 0 over here, but you actually graphed it, I might not have noticed that to give you the point. You know, just I think there was one person that the graph looked great, everything was accurate, and so I did end up grading the graph to get this information, give them full credit. But I didn't want to. I want to grade that work. So then your x-intercepts are going to be also 0, 0, and then also the point -3, 0. 2 is not an x-intercept. And please cross that out. I didn't take a point off, but I should have. We have a vertical asymptote with the equation x equals -1. So let's write those limits. The limit as x approaches -1 from the left of this function is going to equal positive infinity. And this is one where you didn't actually need to write the limits. When you actually go to draw this thing, there's only one way the behavior around these asymptotes could occur. Because I actually made a mistake. When I went over the second period, I accidentally had these limits backwards. But when I went to draw the graph, I knew something had to be wrong. And that made me go back and check them. Does that make sense? And then it turns out there is a hole with an x-coordinate 2, but I don't know what the y-coordinate is yet, so we're going to do a single two-sided limit. So what is the limit as x approaches 2 of this function? Well, isn't that going to be the same thing as the limit as x approaches 2 of x plus 3 over x plus 1, if I cancel those common factors out? So if I plug 2 into this, come back, pen, there we go. 2 times 5 over 3, and so you get a y-coordinate of 10/3. And then finally is the end behavior, which, because it's top heavy, I need to long divide. But even that wasn't that bad. You multiply x squared by x to get x cubed. So x cubed minus x squared minus 2x. When you subtract, you get 2x squared minus 4x. And then what do you multiply x squared by to get 2x squared? So there's, and I don't need to go any further because the remainder is just going to become 0. So what that means is there is a slant or oblique asymptote with the equation y equals x plus 2. So grading wise, there's 1, 2, 3, 4, 5, 6, 7, 8 points. And so then your 9th point is the drawing. So we have slant asymptote, vertical asymptote at, where is that, -1? A hole at 3.3-ish. X and y intercept at the origin, -3. So you follow along the slant asymptote, cross through that x-intercept, go up the vertical asymptote, going down the right side of the vertical asymptote, through the origin, jump over that hole, and there you go. Any questions over number 3? Yes, ma'am. I don't like you. I don't know. I'll look at it. Yes, sir. I didn't give you a point for your limit? For your limit? And you're saying it was right? Oh, you said I might be wrong? Now I'll look at it. Absolutely. All right.